everyone. I welcome you all to today's session, wherein we'll be taking up a question from, you may call it as graphs question or modulus based question, graphs and modulus based question. So I'll just show you the question right in front of you. You can have a look at it and try it out once, and then we'll start discussing. So in this series of videos, as you're aware, I bring forward questions from different areas: arithmetic, algebra, geometry, right? Coordinate geometry, etc. Right? So today I have one question on this area: modulus, graphs, coordinate geometry. All right, you may call it any of the areas. So let's get started as to how do we interpret this. So when you look at modulus, so modulus and all is all dependent on where does the term inside the modulus becomes negative, at what point does it become non-negative. So depending on that, because the definition for modulus, as we all know, so mod x is equal to x if x is greater than or equal to 0, it is equal to minus x if x is less than 0. That's the definition that we have for mod. So that's why I'm saying, at what point does x minus 1 become greater than or equal to 0? At what point does it become less than 0? Modulus would change sign, right? The expression would change its sign. Same thing happens for y minus 1 also. Now there's one more point I would like to share here. Now instead of taking x minus 1 and y minus 1, let us simply take mod x plus mod y equal to 5. I'll tell you why. Now in your functions and graph topic, you would have discussed something called as shifting of curves. Right? Shifting of curve. Right? So translation, right, of curves. So what do we mean by shifting of curve is, whenever you replace in your function f of x, y equal to f of x, if you replace x by x minus a, for example. So if this is the curve, let's say, for y equal to f of x, this is the curve that we are talking about, example. So y equal to f of x minus a will be the same curve, but which is shifted towards right by a units. So this will be shifted right by a units. Similarly, f of x plus a, this will be the same curve shifted left by a units. So the same curve will be shifted left by a units. Similarly, if you have something like, if you have y minus a, so you're replacing y by y minus a, then the curve, same curve, will be shifting upward. It will move up, right, by a units. And similarly, if you replace y by y plus a, then the curve will be shifting down. So that means the net impact of replacing x by x minus 1 and y by y minus 1 will be only the movement of the curve horizontally and vertically. That's it. The shape will not be changed. The shape of the curve won't change. For example, this v remains v only. If you replace x by x minus 1, it will shift right by 1 unit. If you replace y by y minus 1, it will shift up by 1 unit. The shape is not going to change. So thus I say, let's not work on this, but let's work on this. It's convenient. So when you look at this, mod x plus mod y equal to 5. Now depending on whether x is negative or non-negative, mod will change its sign. So let's consider the various possibilities for x as well as for y. So if I take the first quadrant, in quadrant 1, so in quadrant 1 we know both x and y are positive, right? So that means what will this equation become? Mod x will become x, mod y will become y, x plus y equal to 5 in the first quadrant. So here in the first quadrant, both x and y are positive, so that means the curve will become x plus y equal to 5, and by the way, x plus y equal to 5 will look like this. It's a straight line which passes through 5 comma 0 and 0 comma 5. This is your curve in your first quadrant. Now in second quadrant, please note that x is negative but y is still positive. So how would the equation change? X will become minus x, mod y will become plus y only, will remain y only, 5. So the equation will be y minus x equal to 5 in the second quadrant. So in the second quadrant, the curve will be like minus 5 comma 0. Just a minute, I'll just draw it on the right, just a minute, so that it is clearly visible. So we already discussed the first quadrant. So first quadrant will be like this: 0, 5 and 5, 0. So this is the first quadrant line. It's a straight line. And second quadrant, it is y minus x equal to 5, and y minus x equal to 5 will be like this. Now in the third quadrant, both x and y are negative. So then mod x will become minus x, mod y will become minus y. So both minus common, I can write it as x plus y equal to minus 5. So minus can go on the other side. Let me clean this so that okay. So in the third quadrant, x plus y equal to minus 5 would mean it would be as follows. It would be like this. It's parallel. This blue line and this red line will be parallel. And lastly, in the fourth quadrant, what will happen? X is positive, but y is negative. So this equation changes. Mod x will become x. Mod y will become minus 5 because y is negative. X minus 5 equal to 5. So this will be looking like this. So this is x minus y equal to 5. Okay. This is x plus y equal to minus 5. This is x plus y equal to 5. And this is y minus x equal to 5. So these two are parallel. These two are parallel. So it's a parallelogram, right? In fact, when you look at it carefully, each of the side is equal. This will be 5 root 5 because right angle triangle. Okay, we can use Pythagoras theorem. This is 5 root 5. This is 5 root 5. So thus, this shape which is formed is actually a rhombus. It's actually a rhombus that we get here, right? It's rhombus. And when you dig deeper, since this is also 90, these are perpendicular, it will turn out to be a square. So finally, we can say that this equation will give us a curve, a bounded curve, right? A group of lines bounded, which will be in the shape of a square. So now he's asking us, find the area of the region enclosed by this graph. So can I say the area for this will be same as area for this, which happens to be, once you know the side length, can I say my required area is nothing but side square. So it's going to be 5 square into 5, which is 125. So 125 is going to be our answer. Okay, find the area of the region enclosed by this graph. So it is going to be, side is 5 root 5. So 5 root 5 whole square will be 125. Now, a general formula, if you, in the exams, right, if you ever come across, find the area of the region bound by this curve, mod x plus mod y equal to some a, for example. So the area for this, so one thing that we can immediately recall, understand is, this will be giving us, so sorry, this is 5 root 2, just 1 second. It's 5 root 2 by Pythagoras theorem. It's going to be 5 root 2 square. It's 5 square into 2, which is 50, not 125. It's going to be 50. So the formula for this is, so one thing that we can recall is, the moment I see mod x plus mod y equal to a, it will be giving me a square, which will be cutting the axis at a comma 0 minus a comma 0, 0 comma a, 0 comma minus a. Hence the side is going to be a root 2. The side is going to be a root 2. And hence its area is going to be 2a square. Now not only for this, even if you have something like mod of x minus p plus mod of y minus q, this will also be having the same area. So you can maybe note down this formula. So the area is going to be 2 into a square, where a is this 5. So 2 into 5 square will give us 50 as our answer. Alright. So with this we have come to the end of the video. I hope you followed the session, and please make a note of this formula, as I said. Might help you in your competitive exams. So on that note, let me end the session here. Thank you and all the very best.